First of all, thanks for attending this panel. I'm going to explain how it's going to be structured. There will be mainly two stages. First of all, I will ask each panelist to come here and give a brief presentation. It will be roughly 12 minutes. For Katsuhiro Harada, we will take more time because he will be giving the talk in Japanese, and it will be translated, like interpreted by the interpreter. Then after all four talks, I will ask the four panelists to come here on stage, and they will sit down, and we will start the discussion. The discussion it will be open to the public. If anyone has any question, please ask them. So let's start with the first panelist. Let me introduce Alex Olwal. He's a senior research scientist at Google. Also affiliated at the affiliate faculty at KTH Royal Institute of Technology in Stockholm, and also research affiliate at the MIT Media Lab. Before that, he worked at Columbia University, Rhode Island School of Design, and Stanford University. His research includes augmented reality, spatial aware mobile devices, medical user interfaces, ubiquitous computing, and touch screens. He designs and develops interactions and technologies that embrace digital and physical experiences. It is not easy to highlight just one of his contributions, but I would say that his the implementation that he did of haptic displays with pin array has many applications.
Thank you. Thanks for the introduction. Let me take a moment to context switch. Thank you. Okay, it's great to be here at Spatial User Interaction. You can find a lot of my work actually on my website, olwal.com, but I'll try to go through some highlights in my research. And as Aitor described, I'm currently a senior research scientist at Google, but also affiliated with KTH, MIT, and Stanford. And to that note, I just want to make clear that this talk reflects my personal views, not necessarily related to the organizations that I'm affiliated with, and also a little bit reflection of some jet lag, perhaps. Anyways, today we are asked to talk a little bit about the future of user interfaces. We had an amazing keynote by Sharam, also showed some limitations in technology today and how we can transfer information back and forth. But I thought that I'll start with kind of like an anti-example. It's usually an effective way to show what you don't want. And there's a beautiful video, sort of like in the spirit of critical design, by Keiichi Matsuda, called Augmented Hyper Reality. And this is kind of a future where you have perfect tracking, amazing computer graphics, everything perfectly registered, and you just augment every single moment and millisecond of your life with visuals that are even like the most simplest tasks, such as preparing a cup of tea, can be supported. So probably not something that you would want or expect in our future, but it's sort of like he has a set of amazing videos that I really recommend you to check out. So when we think about interface, it's really about the separation of two entities. We have a shared boundary that we exchange information across. So in HCI, it's really the boundary between humans and reality, and we use that boundary to add some sort of augmentation to elevate what we can do. In science fiction, we see plenty of examples where we try to add X-ray vision, or in early pioneering work, as by Ivan Sutherland, we add capabilities to see things that we can't see, basically digital information that is overlaid and registered. But as we try to extend our abilities and go beyond our biological limitations, we obviously will have a profound impact on our experience. And with the advent of VR and we have a lot of opportunities to create experiences that we could never sort of live in like real life. But there's also obviously implications on our existence and our presence in reality. And what is important to think about is, how can we still add to our abilities without disconnecting ourselves from reality through devices and interaction. So I like to think about this in terms of minimalism often. So can we use the technologies that we have at hand, which is often thought as in terms of display, sensing, and interaction, and can we look at ways in which we inject these with minimal implication to our interactions with reality. So here's just like some examples from my earlier work where I'm looking at see-through displays that can bring pixels into midair for midair interaction, extending physical objects with projection, tracking, and recognition. But also maybe early also being interested in using mobile devices as sort of handheld lenses that can enhance visual display and input. And couple that with precise high-speed motion tracking to sort of add to that realism. But these examples are really only manipulating photons and pixels in the world. So we're talking about see-through display, projection, lenses, things that only alter our perception, our visual perception, even if there's like a lot of tangible interaction involved. And a little bit related to the keynote, we've looked a lot at my earlier work at MIT. We looked a lot at bringing these photons to life with shape displays, and very suiting to Shahram actually not being able to be here for his keynote. I wanted to share like one of our projects, which is called physical telepresence.
Physical telepresence. Shape capture and display for embodied computer-mediated remote collaboration. We propose a new approach to physical telepresence based on shared workspaces with the ability to capture and remotely render physical shapes. We explore physical telepresence through 3 different shape display systems. Asymmetric teleoperation with shape capture and rendering, bidirectional interaction through shape capture and rendering, bidirectional interaction through deformation. Our teleoperation system enables capturing and rendering hand shapes for presence and manipulation. Our system is based on a depth camera connected to a remote shape display. Video of a shape display is shown on a horizontal screen, while a Kinect captures the user's hands. Remote experts can, for example, provide assistance and instruction to a local user in different contexts. They can also dexterously manipulate various physical objects. By altering the rendered shape, the remote operator's capabilities can be increased. To avoid obstacles in cluttered spaces, hands can be rendered without arms. Or shape output can be switched on and off to move around objects. Pointing on top of objects is also enabled by this feature. Users can rotate the scene, scale their representations. These transformations can, for example, enable users to handle larger objects. Physical shapes can be replicated and mirrored. By leaving a copy behind, the user can create static shape features. The hand shape can be replaced with different tools to manipulate objects more effectively. These tools include a claw to pick up objects, hooks for reaching, and ramps for sliding objects. Our second prototype enables bidirectional shape capture and output. It renders captured shapes remotely. Remote users can collaborate through connected objects for tangible interaction. Here, two tokens are linked and the remote user's hands are rendered physically. Alternatively, hands can be projected on the surface while the objects remain connected. Here, a remote object is rendered physically by the shape display, and a user can manipulate it through a separate gesture zone above the object. Alternatively, a brush tool allows the user to translate the remote object by pushing into the side of its local rendering.
Okay, so I think like a few things are worthwhile pointing out here, and that's specifically the emphasis on the use of computer mediation, not as an obstacle where we are losing capabilities over a distance, but actually going through the computer to amplify or change our possibilities. So we are basically allowing us to do other things as we have actuated control on the other side. And I think that from my perspective, there's like a lot of related work that is really interesting in this sense. 3D is a freehand digital sculpting tool that also allows the human to work in tandem with this kind of like milling apparatus. And there's actually one product that's recently announced called Shaper, which is an auto-correcting router. And another of my favorite examples is from Lift Labs, which is a self-stabilizing spoon for hand tremor. And I think these are, you know, even if they're solving for very limited use cases, I think this is a very interesting in terms of augmenting and amplifying our capabilities through this actuated control that is in a very tight loop with the human action. So for this panel, I also wanted to think a little bit about sort of like the role of augmentation. I showed that example in the beginning from Keiichi Matsuda. And you know, you look at this video and you feel like, okay, it's pretty clear that we can sort of decide that, okay, this is ridiculous. We need to sort of like dial down the augmentations or the visuals, the graphics. And that's sort of like related to this idea of minimalism, right? But what I wanted to also bring up as a potential topic for questions during this panel is also what happens when we go beyond this boundary of adding to the reality, and we're talking more about reduction. And there's been a lot of, well, there's been like some initial work, I would say, in diminished reality. But I think one of the best examples is from the TV show Black Mirror, and specifically this episode White Christmas, where you have a couple that is fighting, and the woman decides to block her boyfriend, meaning that she can neither see nor hear him, and he can neither see nor hear her. And what's interesting is that this is not only limited to their presence in reality, but also propagates to his memory. So here he looking at old photos, and you know he cannot access any representation of her. Okay, so I think like the question of reality management is something that maybe we also need to start thinking about, and like the consequences of adding and subtracting things from in AR. And for some of you, you might have noticed that you've actually been subject to a little bit of reality management with the SUI poster with me in the center. So thanks a lot.
Thank you again. We're going to move on to the next panelist. Our next talk will be by Otmar Hilliges. He's an assistant professor at ETH Zurich, where he leads the Advanced Interactive Technologies Lab at the Institute of Pervasive Computing. Prior to that, he was a researcher in the Microsoft Research Group in Cambridge. He is one of the authors of Kinect Fusion, and his research interests are in the field of human-computer interaction, interactive graphics, and applied machine learning, and include multi-touch physical and tactile input, 3D and augmented reality technologies and applications. Thank you. You want this microphone?
Yeah, thank you, Aitor, for the introduction. Hello, everyone. Give me just 1 second while I set up. There we go. So welcome again, everybody, to the ACM SUI panel, for the lack of a better title, Chris's Friends panel. And also thanks, Alex, for the great first talk. He put me a bit in the doghouse. Yesterday he announced that he was going to give a slightly more philosophical talk and not just talk about his own research. I did not have enough time to follow up with that. I'm the archetypical Pavlovian dog here, right? You give me a microphone, you give me a stage, I talk about our research projects. That's what tenure track does to you. So, apologies. Okay, so yeah, my group's called the AIT Lab at ETH in Zurich. We operate in a number of research areas. There's kind of augmented reality and virtual reality. I had a bit of an inkling that Sharam might talk about some of these projects, so I'm not going to talk about any of them. More recently, we've done a lot of work with robots in the space of human-robot interaction, which might be relevant for both spatial user interfaces and the topic of remote and telepresence, but I won't have much time to talk about that either. So I'm going to concentrate on our work on input sensing, and then later on computational design for content creation. Again, Sharam already highlighted the need for kind of lightweight but high precision user input in a lot of mobile scenarios, augmented virtual reality, and so forth. And we've done quite a lot of work in this space, and today I want to focus on things that actually run on mobile computers. So this is one project that we kind of presented a couple of years back at WIST, which runs entirely on a mobile phone. It just uses the 2D RGB camera in there and kind of combines the high precision that you get from a touchscreen with very lightweight occasional gesturing. And that's kind of the direction that I think we want to go into, where we use different kind of sensor modalities and use advanced, often machine learning algorithms to kind of recover what the human is doing on top of the things that the user can do by touching the device. I won't have time to go much into detail, but it is important to highlight that this actually runs just on now, I think like 3 generations old Samsung mobile phone, and only uses 2D RGB video runs in real time. Given that we're here at Spatial User Interfaces, I thought I'll show this example too, where we're actually using a related algorithm that again only uses a 2D camera but estimates depth on top of gestural input. Right? So with a very lightweight computing device, very lightweight sensor, you can actually get 3D spatial input. So in the bottom you see that we're actually estimating the depth, and on the left-hand side you see that we're estimating gestures at the same time, which then allows to implement simple augmented reality user interfaces with just off-the-shelf devices. Right? So there's no depth camera involved. All the work that Sharam showed actually had depth cameras. This is just a 2D camera. And here's an actual augmented reality example of this. Okay, so these are kind of camera-based systems. I want to very briefly give a little preview of our talk that's going to be on Wednesday in WIST, a collaboration with Google where we're actually leveraging the SOLI sensor for gesture recognition, which is a very exciting, promising technology that works differently from a camera. It illuminates the scene with electromagnetic energy, and some of this energy is reflected back of centers, reflection centers on the hand. The signal is then processed in several transformations, and we're going to talk about the range Doppler images that you see on the bottom left here. What's interesting about this signal is that it is very, very different from a camera. So here you see the shape of the hand changing drastically, but if you look at the signal up top, you see hardly any change. And this means that a lot of standard algorithms that are built for cameras don't actually work with this type of sensor. However, the sensor is very, very sensitive to motion, right? So here you see how rigid and non-rigid motion actually translates in quite drastic changes. And these are the type of interactions that are very, very difficult to capture with cameras. And the range Doppler image then resolves this in both velocity, space on the horizontal axis, and range on the vertical axis. So I won't go into any technical details of this. The talk is, as I said, on Wednesday. But we built a custom machine learning algorithm that can recognize a large set of gestures across multiple users fairly robustly and models temporal dynamics, right? So it exploits the high spatial resolution of the sensor. You can see the probability evolution over time in the bottom left corner. Okay, so a whirlwind overview over some of the sensing work that we're doing. I also want to talk about devices that we design, often algorithmically design for content creation, right? So with the emergence, re-emergence of virtual reality, we actually have a more and more pressing need for animations for 3D characters that come to life. And character animation is really a tedious task, right? So this is a re-implementation of the state-of-the-art user interface, Maya. This is what real animators have to do. To bring this elephant to life, you have to repeatedly select individual bones, manipulate the degrees of freedom individually, and intersperse this with camera manipulations. So it's very, very tedious job, and the problem really is the mismatch in degrees of freedom, right? So you have a high-dimensional output space and a very low-dimensional input space, essentially 2D plus the keyboard. So we've worked on a tangible input device that you can use for this type of character animation. That gives you a much more natural, much more realistic way to pose these type of characters, right? So here you see a user posing this bunny character with what we call inverse kinematics, hardware inverse kinematics, so a fluid way to create 3D animations. Tangible input devices, of course, have been proposed many times before, and this is just one of the examples. But in this work, we solved one of, I think, or addressed one of the fundamental problems, right? It's all well and good to make this bunny dance, but if we look at slightly more complex characters, such as the dragon here, then typical approaches fail, right? This is 110 bones. Playing Sharam's tricks, close your eyes, right, and imagine what the tangible controller that controls 110 bones in a character looks like. You can open your eyes again. Here it is. So this is obviously not practical, right? This is kind of one of the big problems in tangible input devices, that often when you want to do real world tasks, tangible isn't the right medium. Okay, what we did here was essentially develop an algorithm that synthesizes build plans for minimal tangible controllers that can still control complex characters with sufficient fidelity. Right? So from an input character with some poses that we download off the internet and some of these tangible pieces that we've developed, the algorithm essentially produces a device plan and a mapping that then allows us to control 3D characters without having to build these monstrous controllers. The procedure essentially iteratively assigns joints to bones and splitters, so these gray branching nodes, to two branching nodes in the skeleton. Here's an illustration of the algorithm that builds up the controller, and you can also see the desired pose of the horse overlaid with the pose that the controller would currently induce. And maybe the one thing to highlight is that this doesn't just go through the skeleton and assigns one joint to one bone, but actually assigns them to the ones that are most useful to control the character. Right, so the green skeleton is what essentially controls the character in the end. Let me make sure we have some audio. So this is from the user perspective how this whole thing looks. You go online, you download a character, the algorithm designs this build plan, and then you can start to animate this. And what you may not have known is that the duck dance, the chicken dance, is actually a Swiss composition. So this is our contribution to today's entertainment program. Okay, I think you got the idea. So maybe more interestingly, right, this is the one thing to remember from this, and that the demo is actually out there tomorrow in the WIS demo session, so you can actually download your own characters and have a controller built for you, and then see if you can also do the chicken dance. So the point is really that this is the error in pose that you get as you add more joints, and at some point here, with 10 joints, there's a sweet spot where you don't actually get any more gains by adding more. Okay, so let me resolve this. The monstrous tangible controller, the one-to-one mapping, and then this is the optimized device. And here a video where one of us, so a non-expert animator, created in 20 minutes or so, a relatively good-looking 3D animation of this dragon. And that's really the goal of this project, right? To allow non-experts to create almost expert-looking like 3D content. So I'm almost done. In the spirit of the keynote today, I just wanted to mention that as HCI researchers, we often only focus on the user experience and forget that there's a lot of technical problems, a lot of sensing problems, a lot of algorithmic problems that we actually are very well equipped to identify and maybe are also very well equipped to tackle. And then last shameless plug, we're hiring PhDs and postdocs. If you already have a job, come to our summer school where we teach a lot of the skills that are necessary to do this kind of work. Thank you.
Thank you, Otmar. Thank you, Otmar, for your talk. Our next panelist will be Hrvoje Benko. He's a senior researcher at Microsoft Research. His research interests include virtual augmented reality, computational illumination, surface computing, new input form factors and devices, as well as touch and freehand gestural input. He's interested in the intersection point where the digital technology meets the real world, and among his contributions is the OmniTouch, which is a wearable prototype to use any surface to interact with computers, and also in the Microsoft Touch mouse. Thank you.
Thanks. All right, so in the spirit of this presentation, I was starting to think about what kind of challenges are the designers of future spatial user interfaces facing, and what are they currently missing in their toolbox in terms of things that they can actually apply and make a real difference. So the way that I look at the space of augmented reality and virtual reality right now is that we are all pretty much obsessed with creating a rich sense of reality. The first time you put an Oculus down, this is what your VR living room basically looks like. It's super rich visually and orally. It's very poor haptically, but rich visually. It can teleport you into space. You can conceive of new ways of accomplishing some work tasks, or as Ram has said, there's new ways that we are envisioning communication happening. And in all of these interfaces, we're really limited by a whole variety of things that people in this audience are well familiar with. To solve some of these problems, though, we usually employ tools such as optics, HCI, computer vision, haptics, mechanical engineering, things like that. All of those, both technical and user-driven tools and skill sets. One tool that we rarely do use correctly or at all is prioritizing the concept of perception. And what do I mean by that? Perception is, by definition over here, is the neurophysiological processes, including memory, by which an organism becomes aware and interprets external stimuli. What I really mean by that in our context is there's a difference between what is real and what we perceive as real. And those two things might not necessarily be the same. When we create user interfaces, and particularly AR, VR, spatial user interfaces, we rarely actually try to exploit this difference. Just to illustrate the concept of how our brain actually interprets this different stimuli, and we form different images based on who we are and how we perceive the things, I'll use some of the kind of standard perceptual tricks here just to give you a sense of what's possible. So these are well known in the literature, and the questions are something like this: well, do you see the vase? Do you see the face, or two faces? Right? Depending on who you are, you will first see one or the other, and once you see the other one, you will never be able to kind of unsee it. Is this a young lady or an old lady? Are these lines straight or are they crooked? And lastly, are these moving or are they stationary? And all of these are well-known perceptual illusions. But to really drive this message home, I'd like the quote from Mark Bolas, who said that we need to realize that the world is just a framed and malleable construct that the user creates in their mind. It's not something firm. This concept of reality is interpretation in your brain of all sorts of different stimuli, and your brain can get fooled. And it creates a picture of what reality actually is inside it, that you believe it's real, but it's really just a perception of reality. It's, in many ways, you can think about them as a bunch of illusions, bunch of sensorial illusions stacked together that make a coherent picture of what you think about the reality. Now, that's all kind of fine and theoretical and interesting. I want to drill down and show you some examples. So this is a sketch of what human field of view looks like, right? It stretches basically 190 degrees left to right, horizontally, but only a small portion of that full binocular field of view is actually something that you're able to read text. There's some sort of foveation part. Now, a good example of perceptually driven user interface would be one of the canonical examples of foveated rendering, right? Where you apply the fact that we have two distinct visual systems, foveal and peripheral, and you can improve performance, lower the bandwidth, by lowering the quality of rendering in the periphery. And there's lots of work in this particular domain. The second one is, if you actually take a look at the field of view of our current devices, they're about 110 degrees. I've overlaid them here on this chart. And this is kind of what they give you. They give you this 110 degrees, and the rest of them is black. But if one of the great pieces of work is by Jones down and colleagues down in USC, where they discovered that if they just make the periphery bright rather than the periphery dark, so all you need to add is just white LEDs and some diffuser in the periphery, the standard things that are like the underreporting of distances in virtual reality ends up being more closely aligned to reality than to the virtual reality in there. So in other words, you improve the experience just by perceptually changing the nature of the experience within the HMD. We've taken that a bit further in our sparse peripheral displays, where we just augmented the whole field with a bunch of LEDs in the periphery, and here's a view of what you can see in there. Now, of course, you can expand the field of view. We also show that there's ways to do things in the periphery that help you in targeting, make you faster, potentially lower some of the nauseating effects, etc. Another example of perceptually driven user interface design is stutter turning in Minecraft VR, and I'll let them explain kind of how they did it.
Development has been a very iterative process. We looked at pretty much all controls and how you play Minecraft, and try to figure out like what is the best way that we can do this in VR with the maximum amount of comfort. So like a good example of that is the stutter turn, where we've changed the turning from being a smooth turn into a 22.5-degree turn instead, and it increases the comfort on fast turning, where you don't feel as disoriented, but you still have the same level of control and you don't gain a competitive advantage.
So it's a good example of taking perception as a primary tool to design something. You want to minimize nausea. You don't want to penalize people for using VR system, but you have to create a way to turn that's not as nauseating as before. And they came up with this 22-degree stutter turn. Let's switch gears from output to input. One of the interesting again, one of the pieces of related work that really kind of drives this home of perceptually driven user interfaces to me is a notion of redirected walking, where you have a limited tracking space and you're reusing it, you're fooling people and turning them around to reuse your available tracking space to give you an impression of much larger actual walkable VR space. That same concept has also been applied to kind of more within hands and touch-based interaction. So Coley down in USC did a project called Redirected Touching, where in this video the user is touching a square object, but the user perceives that they're actually touching a curved object because of the visual field is very dominant. So in other words, you fool the person to give them correct passive haptics, but for a different actual virtual object. So we were really inspired by this, and I want to show you this video of the paper we presented at CHI this year. It's called Haptic Retargeting. It was done with my intern, Mari Asmandian, and Mark Hancock as well as my colleagues. And we pushed this idea of repurposing haptics, passive haptics, to kind of the little bit next step, where you can literally engage and touch object, move them around, stack them, and interact with them. So the video is a little funky. Mari definitely had a lot of fun making it. So hope you guys enjoy it.
Wouldn't it be nice to use real cubes to make a Minecraft castle? Well, the best thing you can do in VR is this: moving cubes around with a virtual wand. To have haptic feedback, you'll need a castle's worth of cubes. Luckily, we found a perception hack that makes you need way less. Like, really less. Like just one cube. First, you'll need a Connect 2 mounted above your head. Then a fully tracked HMD, mount a button pressing device to your desk, grab a trackable cube, strap a marker to your hand, and you're all set. For our first magic trick, we'll show you 3 physical cubes on a table. The moment you put on the HMD, we'll quickly grab 2, leaving only 1 behind. You'll see 3 virtual cubes, thinking they map to the same cubes you saw earlier. Then you'll be asked to reach and touch the cubes one at a time. As you reach for the cubes, you'll be wondering what the point of this demo is, but you won't know you're being fooled until you take off the HMD. Behind the scenes, we're using body warping. As you reach for the target, we warp your body space to provide the illusion that you are reaching for a different cube each time, when in fact every time you're touching the same single cube. In another illusion, we use a different mechanism to map a single cube to a ring of cubes around you. After inspecting each cube, you need to face a billboard to trigger activating the next cube. When you look back, the other cube will be ready. You can reach out and grab the cube, and surely the tactile sensation will be there. This time, we are using world warping. As you move your head around, the world ever so subtly rotates around you as well. This rotation is used to align the physical cube with the new virtual cube each time you look to the trigger board. Body and world warping can also be combined to form a hybrid approach. In our haptic retargeting framework, head motions trigger world warping, and hand motions enable body warping. We hypothesize that by splitting the job of aligning between both mechanisms, undesirable artifacts of each method can be mitigated. To put this to the test, we conducted a user study to gauge immersion levels associated with each approach. This minigame uses haptic retargeting to provide the illusion of arranging and stacking different cubes in the virtual environment. As the instruction billboard guides you, each time you place a cube in the correct location, with the press of a button, it will solidify. Then, a new cube will spawn to continue the rearrangement. Though it appears you're reaching for a new cube, you're actually moving the same one. Participants reported higher presence levels from the hybrid approach in comparison to each warp used individually, and overall preferred haptic retargeting over the virtual wand method. With spatial warping, in addition to spawning new cubes, we can also provide the illusion of stacking. This is done by applying a height warp as the cube is moved around. This close-up shows how the user feels haptic feedback from the table, convincing the user that the bottom virtual cube actually exists. With our system, haptics can be repurposed for a richer immersive experience, enhancing the user's sense of presence.
One thing I want to point about this is the whole point of all of these different tricks is that they're imperceptible to the users. In some sense, the user itself is not necessarily aware. If they look carefully, they will discover them, but if they play along with the system, most of these are done in a perceptually salient way, so they're not obstructing and they're not destructive to the actual experience. So I want to leave you with this. I believe to get the best VR AR experience, at least in the near term until we can get these fully spatial volumetric displays, I believe we should cheat as much as possible, but we should cheat in a perceptually salient way. We should not let the users perceive them, but use all our perceptual tricks to actually enable that. So the challenges to the community are really how do you extract some of this generalizable knowledge? There's lots of individual principles, individual tricks that are available for this. How do you actually build up a more coherent body of knowledge that would apply these techniques to a variety of different scenarios, as well as how do you use neuroscience and cognitive psychology more effectively in AR and VR? So thank you very much.
Okay, well, thank you very much for your talks. I hope that the audience has a lot of questions for you, but first of all, I wanted to start the discussion with very general questions. Do you see me there? These questions are not focused on anybody, so anyone can answer. So basically, what's going to be the next breakthrough, the next game-changing in human-computer interactions at the same level it was for instance, Kinect or the virtual reality head-mounted displays? Because we saw that in the way that people has been doing research or the people has been doing enjoying entertainment, so it has changed a lot after these devices have been released. Also, I have another question. It's about haptic technologies. How far are we to implement realistic tactile and kinesthetic feedback? Because Benko, you've been talking about some haptics, and Alex too as well. So Who wants to answer?
I'll answer the second one. Somebody else can take the first question. I think haptic is really hard. Haptics is many people actually really feel strongly that vibrotactile solutions are offering us a way to get there. I think I look at them as mostly kind of band-aids because it's not realistic what they can render. They don't render human scale forces or feedback, things like that. To me, the opportunities in the short term that are the most promising ones are the passive haptic solutions, and those necessarily don't scale. That's why actually what we are exploring is the ways to actually make passive haptic solutions that could scale to more than just a single instance or single object. But I don't think I have a good kind of general solution for haptics in VR. It's a tough one. It's going to require a lot more research and a lot more effort. And that's good. It means we all have a job.
Yeah. Alex, do you think that you could be able to implement like a wearable high-resolution pin array, like the ones that you've been showing?
Yeah.
Just to give the haptic feedback.
I think that, actually connecting to what Benko was saying, I think there's plenty of opportunities to look beyond current approaches and current approaches that were chosen because of manufacturability and scalability, etc. Starting with sort of the vibrotactile actuators in our mobile devices. But I think that also, what other sensations are becoming interesting as graphics capabilities move beyond like polygons and shaders. So what are things? If you look at the pin arrays, I think that represents a very limited subset of that output space. But what happens when you go sort of like sub-millimeter sensations, or start to think about burning, shear forces, and also larger scale forces on the other end of the spectrum, what's more like even more dramatic robotic displays. So I think that we're just looking at a very thin slice of the spectrum. That's why I don't want to sort of cheer up one particular solution. Sort of like tying back to Ivan Sutherland and the ultimate display. There's no one-stop solution right now, and I don't think there's going to be one. So we just need to sort of continue our search along the spectrum, both in bigger and smaller scales. To avoid answering the question.
Yeah, I have one, and this part shameless plug part, and kind of tying to Alex's. I actually think one platform where haptics and haptic feedback really has a lot of potential is the controllers for virtual reality. I think right now people, the design of controllers is again mostly vibrotactile, but I think that they offer a platform that's relatively constrained, but it's actuated in your hand, and pushing more on that particular platform or particular devices, I think it's very, very powerful, particularly because I think that the other kinds of VR haptics for hands, in particular like gloves and robotics arms, they all have lots of other constraints that make them kind of unappealing to use, both from sizing, sanitation, being able to put them on and off, being able to give somebody else a device to use, and all kind of things like that. The controllers end up being a good platform. We have a paper at WIST and a demo tomorrow that will show a couple different ideas on doing more force feedback on the VR controller headsets, VR controller handheld controllers. So come and try it out tomorrow night. They're called normal touch and texture touch devices.
Sure. And what about the kinesthetic? Would it be possible to make you feel like maybe higher gravity without hanging weight from your feet?
Can you repeat that, please?
like kinesthetic feedback, or feeling the movement. Like it's like feeling that you're moving faster than what you actually are.
I guess, yeah. So we haven't answered your first question.
Not really.
But I guess implicitly these guys have, right? Like so, it's hard to predict what comes next. No one was banking on depth cameras to change the world, and then they happened. Apparently, everyone right now is banking on haptics, and I think it's like if you look back at Ivan Sutherland's quote about the ultimate display, fundamentally that is a quote about haptics, right? He talks about bullets that can kill you. That's hard to render. But I think the problem really is that pushing light is much easier than pushing actual matter, right? Like just on a physics point of view. And kinesthetics and those kind of things are large forces, and large force haptic feedback will be, a couple more years out than even fine-grained tactile feedback. And I think we're nowhere near the resolution that we would want for tactile feedback at this point. Of course, it's great if people are already working on large force feedback, but that's a hard problem, I would say.
Yeah.
And I think in the meantime, right, there is actually a lot of things that are emerging in the material sciences and the engineering disciplines that may change haptic feedback soon. I think the sweet spot right now is to leverage our background, look at software, look at Benko called it cheating, right? Look at algorithms that can kind of take what mechanical material sciences can do at this point and play tricks on our perception, right? So to some degree figuring out where to best place like fewer density or lower density tactile grid is going to get you almost as far as trying to engineer a high density tactile array.
And what about in video games? Could we take advantage of haptic feedback, like more realistic haptic feedback?
I think this is for our
sister.
ゲーム業界の場合は比較的、あまりそこまでリアルな、フィードバックが得られるものじゃなくても疑似的に映像と合わせて、体験させる手法っていうのがもうすでにあるので、割とそっちの技術よりかは、もっと手軽にみんなが装着できるものっていう方にゲーム業界の方は注目してますね。
About in the game industry, so we are not really looking at that level of the reality yet. So rather, when we're talking about the feedback, so what we do is really sync with the image or the video, and really the player will have a better experience. And really the focus in the coming year would be what is really something that easy of use, and what will be the easy wearable. That will be our focus.
Well, thank you. At this point, I would like to open the microphone for the audience if anyone wants to answer or ask any question to them.
Hi. It's related to what Benko presented, but I guess it's an open question. I certainly share the view that there's not a reality. Each one has a perception of reality, and that's not limited to AR or VR. It's like how we deal with anything in life, basically. People have different views. There was a lot of focus of visual and then haptics. Wouldn't it be like the ultimate cheat to go directly to the brain? How do you see it, the brain-driven interfaces? Can you maybe discuss it a little bit?
I've looked into it. Sure. Yeah, so that's probably the holy grail, right? In everything we do, I think the three of us, we have quite a bit of background in user sensing, right? The ultimate sensing channel would be to directly figure out what you want, right? So directly go to the source of what you want. And I think the same thing could be said about creating illusions or creating experiences, right? If we want the ultimate experience, then like direct direct brain stimulation would be the way to go. But talking about technologies that are a couple of years out, decades, centuries, or may even be infeasible, right? A lot of people actually have tried to directly stimulate the brain, directly create experiences there, but as far as I know, a couple of years back when I looked into this, everyone creates different patterns, even if they're seeing the same thing, like neural activation patterns, so it's going to be very difficult to actually render to the brain. But there is, of course, interesting bioimplants, right? Like people are directly stimulating the visual nerves, people are interfacing with the peripheral nervous system, and I think there's some funky stuff down the road. Is that roughly what you were? Yeah.
I mean, fundamentally, I think directly interfacing with human nervous system is really challenging, just purely from like a biomechanical ways of like accessing the nerves, and then also from the fact that your body is different, and the way that your brain interprets these things or learns to interpret the reality is actually affected by how your body acts in reality. So as Otmar said, everybody kind of processes it slightly differently. We have so far identified areas of the brain that correspond to, your visual cortex, your audio cortex, things like that. But nobody really knows which neurons in your brain correspond to, how you process very specific emotions or feelings, or how do you synthesize different things. I mean, we all have in our minds this picture of reality, right? But even that, just this image of this room that you guys are all seeing right now, it's mostly memory. It's not really real, right? Like you're only seeing about 2 or 3 degrees of some sort of detailed vision. The rest of the stuff your brain backfills from memory. So your perception of right now is mostly actually memory. And it's actually hallucinated as well, because you're literally filling in all the extra information, and as your eyes get drawn to it, as your ears get drawn to it, you end up backfilling that particular part of reality. So I think directly interfacing is not something that's on the horizon in the short term right now, unfortunately. I think there's a lot of important research for it, and really promising, probably lots of PhD and careers are going to be made on this. But in the short term, I really agree that there's ways to interfacing with our bodies and with our senses that are not necessarily that invasive, that can still fool you and give you the illusion of a different kind of experience without necessarily doing all the way. One of the most difficult ones, I think, are the vestibular system and dealing with the actual, sense of your body going through motion, or your body going through kinesthetic operation, like you're picking up an object, you're feeling the weight, you have cutaneous forces in your skin that are actually stretching. Those are all really difficult to synthesize, but yeah, again, projects to do.
Yeah, no, I actually want to connect to what Benko said here on invasiveness and, what is the definition. I think everyone has a little bit of a different definition of what interfacing with the brain actually means. I mean, if you think about it, there is the brain itself, but it extends through your body, through the nervous system, right? So by placing the feedback and the sensing at different parts throughout the body, you're actually interfacing with the brain as well. So I think that there's some very lo-fi approaches that also helps us answer questions, like people who implant magnets in their fingers is a very, sort of a very quick feedback loop that directly gives you sort of intuition, right? So you're not talking about interfacing through a computer or something that's sort of coming from the outside. But this, so I guess the question for me is, what does it mean to interface with the brain? Is it to reach that level of intuition, or is it actually to generate those signals directly on a chemical level inside sort of like your brain tissue? So that's one aspect. The other aspect is, I think, what seems to be pretty feasible in the near term is functional near-infrared spectroscopy. So in terms of being able to actually not read your thoughts, but to monitor activity in your brain. And I think, in terms of equipment and apparatus, that has made tremendous advances over the years, and I think that's like one technology that could actually potentially fit in a small form factor and do non-invasive brain sensing, sort of in the coming years, so not centuries away.
Yeah. Let me ask you a question continuing to that. It's like you're talking about the ultimate trick, that trick that the person doesn't know it's being tricked. Have you considered the ethical implications that this can have? Especially put it in the example of more vulnerable people, like children. Children can't believe that what they see is real.
I think it's a great question, but I feel like we have multiple examples of various different technologies and things that we don't even consider technologies. For example, you can be persuaded and you can be tricked and fooled with a book, right? It's a written story that you construct in your mind, and you can be inspired to do great things or evil things or bad things, and the fact that a written text can make you, follow an unethical path or inspire you to do things that are not necessarily great doesn't mean that literature is evil and that all of a sudden you shouldn't use this technology. It's about how you use it and what you do with it, rather than is something good or bad in some sense. All of these ways, all of this different media has a way of being used unethically. And I think it's up to the designers and creators to actually use them in nice ways.
Yeah, but I think that children can really know when they're reading a book or when they see something, they turn their head in virtual reality and they see things, and they can even believe. Like there was a study at Stanford University that was saying that they asked children 1 week later, it's like, do you remember what you saw last week? And half of the children thought it was real.
I'd like to second what Benko said, right? I think this is just media, right? And there's nothing more manipulative than other people telling you what to believe or what not. And it's always down to interpretation. Yes, VR and related technologies are going to be more sophisticated, but very simple things can fool you often, right? Like repetition is number one. Like just repeating the same thing over and over. You don't need fancy rendering, nothing. We have proof, right?
Politicians know that quite well.
I was going to say, no one would vote for Donald Trump if that wasn't true.
True. Any question from the audience?
My name is Benjamin Utram. I'm at Keio University in Tokyo. I think of mixed reality and augmented reality, virtual reality as kind of a new generation of media technology. And if you look at the history of media technology, like paintings or literature or the radio, the internet, every successive generation, when it's created, and the creators often of those technologies don't really anticipate how it's going to revolutionize society in the future. Or if you look at painting, it completely changes. Like later on, abstract paintings look nothing like when painting was invented, and literature now is nothing like when literature was invented, and television and film now doesn't look like, and the internet now is nothing like when the internet started. So my question to you is, do you have any kind of broad visions of the kind of technologies that we're creating today, how they might be completely rethought and reused in completely new ways by future generations?
I think, like in general, right, technologists just live by that assumption that someone's going to go and do something else, right? Like, I mean, Jun Rikamoto Smart Skin, no one thought that would turn into an iPhone later, right? At the time, if you had asked someone, maybe not directly, would you want to type on a flat piece of glass, you would have said no. Now you do it all the time. And I think like when we go and create technology, we live by this assumption that probably what we have in mind is not exactly what it's going to be used for later on. So at least that's my basic understanding of this whole thing. Maybe it's like a rejecting responsibility for your creations and saying like someone else is going to figure it out. But to some degree, I think you have to.
Yeah, I have I think I'm completely agreeing with Otmar. It is really hard from our perspective to predict the creative ways that the new technologies is going to be used. Because the first wave of creative use of new technology ends up being replicating the existing technology in this new medium. When you think about transition between photography and movies and film, the first things was you take a camera, even though it's a moving camera, you put it statically and you film a train coming in and out, right? Like you don't have any of the visual language that you've developed later on. You don't have the panning shot, the close-up, the zoom. Like you don't have the vocabulary to talk about the new medium because you just don't even know what it is good for. At some point, you end up the people immersed in that particular media start developing a language around it. And that's where you really start having a dialogue. That language becomes something that becomes authentic to that particular media. As long as we're using the language of prior media to describe this new one, we don't really know what we're talking about, and that's fine. We're just not there yet. And I think that's where we are with VR right now or in AR. We use the language of game engines, and we use the language of computer graphics and computer vision and all that kind of stuff from technology perspective. But from even creating it, like how do we actually think about creating these stories? I think it's interesting to look at the examples in Summer Lesson that you have to rethink that everything is first person. You have no control of the camera. You have no control over the user's actions, but you have to direct them in a different ways. You can't direct them by moving the camera. You can direct them by things in the scene. So we need a vocabulary for talking about changes in the scene that are designed to direct your attention, for example. We don't even have words to describe these things. So I think that's when you're going to start seeing the kind of a new medium really take authentic use of that medium, and I think we're still a little bit far from there. But it's coming.
Okay, here's something that's less meta on the topic of language. I think that, and this may sound crazy or not, but I think that there's something interesting with us as humans. We're like sending stuff out of space. We're trying to find extraterrestrial life. We sort of want to connect with other awareness. But what I think is fascinating is that we have plenty of animals and insects and bacteria like around us all the time, and we can't even have like the simplest exchange or understanding of what's happening with them. There is a little bit of research. Thad Starner is actually doing work with dolphins and dogs and using HCI as a way to sort of simplify communication. I mean, if you think of how we've been interacting with dogs, it's been completely analog. We teach them things and they do stuff, and but there's never technology involved. So I think it's actually very fascinating to inject technology and the interface between us and other species to help translate and help us sort of broaden the ways in which we can connect. And it relates to all these other things that I think Benko explains very well in terms of like how our perception works and the ways that the mind deals with reality. But this is all things that we can perceive, right? So what happens when you add an extra layer that allows us to, whether that is seeing through the floor, or seeing into the whatever organisms potentially live in this fabric of these chairs, right? So that creates sort of like new both opportunities but also challenges for our awareness. So I think that's kind of like exciting to see where that will go.
Any question?
Hi, my name is Jason Orlowski from Osaka University. My question is for Mr. Harada. So you said for the bank robbery games, you sort of don't want to go outside and actually rob a bank. From my perspective, I've always wanted to get outside, in particular to shoot zombies outside, and actually get exercise. I don't like sitting all day. what are some of the barriers for you personally and technologically, do you think, for realizing games, especially mobile augmented reality, in outdoor environments?
そうですね。ポケモン GO なんかはすごくいい例で、やっぱ生活の中に、ゲームを取り込んだ、非常にいいエグザンプルだったと思うんですけど、ただあれもやっぱりちょっと健康志向でやっぱ外を歩くっていうことが前提になっているので、割と可能性があるとしたら、僕はもう少しちょっと違うアイデアを今ゲーム業界では僕自身もそうだし友達と話したりしていることが一つあります。
So the Pokemon Go is one of the good example that they're going outside because that Pokemon Go, the game is incorporated in a daily life. So it's more like a well-being type of the game, but I have a possibility that I have a different idea going outdoor, and that's been really talking to my friends.
やっぱり外に出て、我々必ずしもリアルな人に会ってるとは限らなくて、意外と携帯電話で人と話したり、もしくは、ネットのデバイスを使ってチャットしたりしてますよね。で、そういうもので話してる相手が必ずしもリアルの人間か、人工知能かはわからない。で、加えて、VR とか AR とか VR の技術を混ぜることによって、我々の私生活の中にちょっとした、本当は存在しない人間がいて、その人間が自分の、生活の中ですごく刺激的な、なんか刺激的なことを与えてくれる。例えばそれは恋愛でもいいと思うんですけど、少し毎日ワクワクするような気分にさせてくれる存在が、実は自分の生活の中に、それは本当の人間、チャットしてる相手、話してる相手が本当に人間なのか、AI なのかはわからないんですけども、でそういうことがこういういろんなデバイスを使って私生活に仕込んでいければ外に出るのはちょっと楽しくなったり、ある場所に来てって言われて誘導されて行ってみたりっていうことで経験値がこう増えていくっていうようなちょっと面白い遊びはよく、我々の間ではゲーム業界のクリエイターの間では話されています。
So what I've been speaking to my friend is this is the idea. So going outside, usually you may meet the actual humans, or perhaps that you are on a smartphone and chatting with your friends, or you are on the internet, and so it's not necessary that when you are outside, you are not really seeing or interacting with the real people. So regardless, it's a real human or AI, so I'm thinking about just to incorporate the AR or VR technology and then put it into my daily private life. So that will stimulate my daily life. So perhaps can have a new romance with something with the VR or AR technology. So and then my life will be more exciting, perhaps. So maybe and then the person may not know if you're dealing with the real person or not. So that's the idea that I've been talking to my friend, and using all the different devices, and your daily life will be more enjoyable. And then by those, perhaps that AI human, I may be really trigger you to something very exciting. So then I can really, my experience will be much more fun.
A quick question to Harada. Go ahead, you first.
I just want to throw that out there as a follow-up from what I said earlier. So I think it's like fascinating with AI and synthetic content. But what if I could go out and speak to the birds that are sitting around? I think that would be exciting. And what could I learn from them and their singing and all these things? So maybe that's something as a challenge for us as designers of whatever the next Pokemon Go. Right?
So we've talked about summer lesson, but it hasn't been included in the international package. And why is that? First of all, if you could explain why it's not released outside Japan.
そうですね。一つ技術的な壁が大きかったです。今 喋ってる、やっぱバーチャルリアリティの中ではこの口の動きがすごく重要です。人間って意外と見てないようで、しっかり人の何を喋ってるかって口の動きで意外と見てます。これを英語のセリフで、しっかりやろうとするとすごくまた、コストがかかるので、一つの言語ごとにコストがものすごく増えていくので、単純にもう少し、日本でサマーレッスンが売れて我々が儲かれば海外でも展開できると思います。
So, because there was some technological hurdle, so for instance, the virtual reality, so you may not know the move of the mouth is quite important. And the real world, when you are talking to somebody, you are looking at the person's mouth and then really understand, and that's how you communicate a lot of time. So, just to put the English and just really align with the mouth movement, that is a lot of challenge and cost a lot. So perhaps that if the summer lesson in Japan, if we can generate more sales, and perhaps that we can have some investment money to launch in different countries.
あともう一個理由があるのは、先ほどもちょっとおっしゃってましたけど、面白いことに今まで四角い画面の中でやってたゲームをただ VR っていう世界に持ってきただけで、これは非常に思想とかいろんなものに、価値観とかにですね、大きく影響して危険なものなのではないかというふうに、やっぱりゲームはすぐ非難されるメディアでもあるので、割とアメリカからそういう非難の声もあったんですね。 VR ってそんな没入感の高いところに人と本当に会ったような気分にさせていいのかっていうことはかなり言われたので、そういう抵抗感に対して、ワールドワールドで一斉にリリースするのはちょっと難しいなという考え方もありました。
And also that we used to have in a very square screen that how we play the game, but in a virtual reality, it's really really wide, all the different scenery, and some people think that it's really the dangerous way of the interact. So because really it may impact on the individual values. So especially in the U.S., actually many people condemn this type of the games, and really to see the people, and we see some resistance of the new idea. So just think about the worldwide launch. Because of that, some issues, that challenge that we've been facing. So that was another reason that we haven't really launched in other countries.
So because I read that perhaps it was not released because people didn't think that it was like appropriate for certain children. Is this true?
そうですね、子供に適切じゃないというのは、どっちかというと子供に適切じゃないというと、こう光学レンズですね。立体視の視点っていうのは、別にこれ VR に限らず立体視のテレビの時もそうでしたけど、子供の脳みその中でこう実際のリアルの世界での距離感っていうのをしっかり認知できるようになってからじゃないと、ちょっと、視覚の目に、影響があるんじゃないかというふうに予測されているので、できるだけやっぱり10歳以下の子にはさせないとかいう規制も業界的には自粛でありますね。
So especially not about the appropriate for the children. That's not the reason, because for that type of the game using an optic lens for the 3D, so looking at the children's brain development, so any children age younger than 10 years old, still their brain is developing, but just to introduce this type of the technology, it may affect on some visionary, some impact in the brain development. So that was really the reason.
Any question?
I have a question. I don't know if this works. I'm breaking reality here. It's actually a follow-up on summer lesson. So I was always fascinated by the multitude of characters in the Tekken series, and there's always great diversity. I guess you could be a panda, you can be all sorts of things that you can't be in reality. So are there any considerations or thoughts to include other characters that you could tutor? Not words, but yeah, in VR.
VR の中に出すキャラクターとしてなんかユニークなものがってことですか?
So you were asking about any new characters in a VR. That's what you asked?
実は結構おっしゃってるところは我々実はチャレンジする前に真っ先にもっと面白いものないかと思ってすごく考えたんですけど考えたところやってみたんですね。やっぱりいろんなキャラクターを我々持ってますからいろいろ出してみた結果我々が勝手に想像している面白いものよりも自分たちが今まで出会ったことがあるもしくは見たことのある例えば近所のおばさんとかでもいいんですけどそうリアリティのあるものの方がやっぱ人間のどうも VR って先ほどおっしゃったようにやっぱ経験をもとにして見てるので脳の中にその人の脳の中にある経験上ある人物を出す方がすごくリアリティを感じるっていうふうに思ったので実際はちょっと空想の世界に行くよりかは我々まずリアルに会ったことある人っていうのをテーマに、やってますね。
So, actually, this is very interesting that we've been always talking about, and we have so many characters, and that was a really challenge that we tried to create the new characters. And a lot of time that we first off always think about something that the unrealistic type of the characters. But in fact, so more interesting is really the character or type of the person I personally have met or actually have experienced. For instance, really the mid-aged women who lives next door, and that type of the character will be more realistic. So that I found out compared to something that out of my really the real life. And then somebody mentioned that really what we see, what we perceive is based on our memory or experiences. I think that will echo, and that's how we would like to create the new characters, and that will be much more fun.
Okay. Unfortunately, we ran out of time, and we'll have to end the panel here. But if you want to carry on with the discussion, you can meet outside in the hallway. Very well. So, again, thank you very much to all the panelists. And last but not least, we have a present for this panelist. This is a talk that was made by